Hey, Rustaceans! Let me tell you about the latest Rust Dortmund meetup. You are also free to navigate through the videos via the YouTube chapters, but I have to thank some people. First of all, Timo Kösters, who did an amazing job with a nice introduction presentation for Rust and prepared a workshop with very great results that you can see now. Second, the Student Council of the Computer Science Faculty of TU Dortmund, who helped with finding a seminar room. And last but not least, I have to thank me because sponsoring pizza and drinks for the event. And well, all that said, what to expect from the video. So we will start with a short survey, 5 minutes, having some fun, getting to know what kind of people are at the event, and then we hop into the presentation. Before we do that, I'm Tim Janus. Have fun and stay efficient.
Okay. So I'm not sure who's in with the smartphone. Yeah, there are some answers already. What programming language did you use so far? So very interesting. So far we have a lot of Java programmers. I think that's typical in Germany. We have a strong Java force. Also C, C++.
Never use it. That's different, but I checked it.
I see. But it's very, well, let's say we're quite diverse group, at least from the perspective of using programming languages. So I think last time I had a counter, like how much time there's left. I will just go for now. And yeah, what is your background in software development? Is there a timer, by the way, on your smartphone? Like how much time you have left to answer? Okay. Oh, I think then when I duplicated it, I did something wrong. Yeah, single choice. Is single choice working for everyone? Yeah.
I'd like to check all.
Yeah, you have really to go for one. What is like really your expertise? So how many of you want to go for more than one? Okay. Yeah, there's some generalists in the audience. Very nice. We still have some votes incoming.
Especially state the difference between application development and web cloud development. Aren't these applications?
Yeah. I was thinking about like web cloud development, more like distributed systems, and applications like more traditional, but you're probably right. It merged. All right. So, how is your experience in Rust so far? So, you can choose multiple items now. So, today is the day. Like we get a bell curve maybe. No, not exactly.
We have Rust professionals. Great.
Yeah, there's some Rust adoption already in Germany. Like, I think in the last Rust survey, they had like the question where if you work professionally with Rust, and a lot of people who answered yes were actually from Germany. That was quite interesting. There we come to the bell curve. Now I will go further. Otherwise, maybe the bell curve was gone. How would you classify your experiences with Rust? So, interesting. Like, I remember the last time we had this meetup. We had more experts, voting experts. But I think this is yeah. This is probably a similar distribution like it was yeah, as before. Okay, I hope this is, come on, I have a word cloud, but then we're done.
Oh no.
Okay, connect is good. So, pizza will be coming. Yeah, actually when I was broke, I got to all the meetups because there's free food. Yeah, learn is hello world. Yeah, I think we will manage that quite early. That looks very good. async Rust. We want to see Axum. We have 3 drinks. That's good. Mirrors. I don't know what that means. Okay, share knowledge. Thank you very much. And I think with this, I hand the microphone over to Timo.
All right. Hello, I'm Timo. I'm holding the workshop today, and I have a small presentation on the Rust basics. Small presentation, like 1 hour. And this seems like a lot, but there's a lot to go through, and I'm trying to start at the very beginning with Hello World, and going through all the main syntax of Rust and what you need to know to get started. And then on the worksheet, you can already see we will continue with some exercises, basically, to build a client for a web server. And last week or some time ago, I wrote a server which handles some commands like /connect and /send. And you can already connect to the server with these commands when you try it out on your machine. But we will write a Rust client that does this for us. And we learn about a lot of things on the way, like how to handle JSON, how to handle command line arguments, and so on. But as I said, we will start with some basics. And I hope, so I always have a comparison to a programming language we hopefully all know. So why would we even code in Rust? So I wrote down some things I really like about Rust. First of all, the Rust-C compiler, which has great compiler errors. Like, for example, this one, unknown start of token, which looks like a semicolon, but it's actually a Greek question mark. And the Rust compiler knows this and has a recommendation to say, don't you mean the actual Unicode character for a semicolon instead of the Greek question mark? Which is really funny. They have so many error messages which really help you as a beginner. Like, all beginner questions are answered by the Rust compiler. There's Cargo, the package manager for Rust, and it helps you set up a new Rust repository. And some additional tools which help you write better Rust code. For example, Rust format, which automatically cleans up your Rust code, makes the syntax align with everything else. And Clippy, which helps you avoid some bad patterns. We will see that later when we are coding ourselves. So the second term, performance. Rust is native code, compiles to native code instead of running in a virtual machine or something like Java or JavaScript or Python. Rust doesn't have a garbage collector. In Java, when you allocate a bunch of objects, after some time, Java needs to clean it all up again. And this is the garbage collector. And this is really annoying for some applications like, for example, self-driving cars. When you have a self-driving car running onto an intersection, and then a garbage collection cycle happens, which takes like 200 to 500 milliseconds in some cases, you don't want the car just going onwards. While the system is garbage collecting, no code runs. It's all freezed, while Java goes through all the RAM and sees what it can remove. So Rust doesn't have that. Rust has, I think it's called RIAA, R-A-Y-Y, something like this. RAI, resource acquisition is initialization, which means resources are automatically freed when they leave scope. We will see that later. Zero-cost abstractions is a nice term. It means basically you can do a bunch of things, a bunch of pretty patterns like iterators and so on, which all get compiled down again to simple loops, which makes your code a bit cleaner. Rust is really powerful. You can have embedded code in some cases, or you can write entire game engines with it. Maybe I can show some of my projects. Let's see. How do I open the internet? Can I open this one? It's fine. Okay. You can tell Firefox is not written in Rust. Okay. It is a bit. Okay. For example, I wrote this thing, which maybe works. So this is Rust compiled to WebAssembly, and it doesn't work. Oh, there it is. This does 3D calculation in WebAssembly, or basically on the GPU. with some GPU shader code, with a rendering engine written in Rust, all ported to the browser using WebAssembly. It's pretty nice. You have a formula at the top here, and you can change some numbers and see what happens. Yep. Yeah, for a bunch of other projects, just look on my Mastodon. It's linked as well somewhere. Can I get rid of the mouse? Okay. Why is? Okay. You have to worry about the thing now. Rust is really robust. When you write some dangerous code which might crash the program, it always stands out to the programmer. For example, the .unwrap pattern, maybe you've heard of that before. When you use .unwrap, it means, hey, this code could have an error, but I'm okay with the program crashing at this point. And later you can just skim through your program and see, oh, this unwrap, maybe we should care about that. And this unwrap, maybe we should care about that, and just on a skim, see what you need to do to write more robust code. Error handling is simple. In Java, for example, you have exceptions to handle errors, like runtime exceptions you need to catch again. In Rust, it's all just return types. Instead of returning an int or maybe an exception, Rust returns a result with an int maybe in it. And as a programmer, you always need to worry about how to get the int out of the result. We'll see that later. And finally, we love it. Rust is the most admired programming language for 9 years in a row, according to the Stack Overflow survey, which means of all the people that currently code Rust, I think 84% want to continue using Rust, which is the highest number for all programming languages. Yes, and you have great errors like this. We all know Haskell on the left side, which is the Hello World program. And on the right, you can see the Rust Hello World program, which should be easy to see side by side how it works. OK, maybe we look at Java instead. Hello World. Well, you don't need classes. There are actually no classes in Rust. Instead, you have structs. And structs don't have inheritance, which is one of the main differences. Some would call Rust still an object-oriented language. Some don't call it that. It's a bit up to interpretation. But you have objects and assign functions to that object. So it's still, I would still call it object-oriented. Yeah. You will notice println has this exclamation mark right here. This means println is actually not a normal function you can call. It's a macro with some special features. Every time you see this exclamation mark, it means this function can do some magic things. We'll see that later. All right. Rust has some primitive data types. On the left, you can see Java again, int 13, float 3.14. You see the same thing in Rust with the let keyword. You don't need to indicate the data type in most cases. Rust will know, oh, when you mean a number, you probably mean an int. When you write this, you probably mean a float. And yeah, when you want something else, you can write it. Rust is type safe, but it can infer the type you mean by what you write. Yeah, there are characters, strings. And this is one of the magic things that the println macro can do. It can have a variable number of arguments, which normally functions can't have. But with println, you can have these points, 4 points here, and we insert later 4 arguments. And Rust will put, or the println function will put the integers or the values inside these, which does the same thing as the println over here with the spaces. And you will also notice we have this final keyword on Java here. Do you know what final means? Hands up, who knows what final means? OK, interesting. Final means you can't change the variable later on. When you set it once, you can't change it again. And in Rust, this is the default. When you write let my
Type or the value? The type.
The variable is.
Is it a const or can't you change the type? For final, if you define type.
I'm not so sure about how Java exactly works. But what I mean is when you write my int is equals 13.
It's a constant in other
Yeah, it's a constant.
languages.
You can change it to 14 later on. It's constant at 13. And in Rust, this is the default, actually. And when you want to change it later on, you need to write let mute, to write a mutable variable. This is one of the design goals of Rust, to have safer code by default. And when you are sure that most things are not mutable by default, you can avoid a whole class of bugs. Like later, you want to change my int, but You actually meant another integer, it was shadowed, whatever. This is a bit safer. All right, type conversions. In Java, you can write int in parentheses to convert a float to an int. In Rust, you can write the as keyword, for example, to make a float to an int. You need to be a bit careful about the as keyword. When you write a 32, okay, first of all, what does this i32 mean? It's an integer with 32 bits, which is the same as an int in Java. But Rust also has i64, i138, 28, and so on. I will show that too. Let's see if, yes. No. Yeah, Rust has these basic integer data types. It goes all the way from a single byte, which is an unsigned integer with 8 bits, all the way to 128 bits, which would be, I guess, a long in some programming languages. Rust can handle all that. And yeah, when you want to convert it to a string, you write dot to a string, which in Java would be integer dot to string my int. Is it really like this in Java? This feels a bit weird. Anyway.
There are alternatives.
Yeah, I couldn't write my int dot to string because
An object.
yeah, because Java differentiates between is this an object or primitive data type, but in Rust you can have functions on primitive data types. Okay, loops. This looks basically the same on both sides. You don't need the parentheses here on the while. And instead of plus plus, you have to write plus equals. Rust does not have the plus plus operator. For the reason that plus plus is a bit weird. You may know I plus plus, but there's also plus plus I on the other hand. And it does some weird things about incrementing it and returning it. So Rust makes it a bit safer by not worrying about this and just write plus equals 1. It's a bit safer. It's always a bit safer. These design decisions all have the same goal. Yeah, while loop, here's the same as a for loop. And in Java, you probably would write it like this, a new integer, count it up, similar to your while loop here. In Rust, you can also put a range here. This is the range from 0 to 10, not including 10, and just writing all the integers. And Rust only has this for I in type of loop. Okay, control flow, it's also the same. One interesting thing, instead of while true, you can write loop in Rust. And this is basically the same as while true. And you have to call break to get out of it. Yeah, break is the same, continue is the same. You will notice it's pretty much the same. And one interesting thing about Rust, everything is an expression. What does this mean? When you have this if, for example, and you notice this line true and this line false, there are no semicolons after this line, which basically means this is returned from the expression. And when it's returned from this if, so either in some case true is returned from this if, or in the other case false is returned from that if. And this is then assigned to the x, because let x equals, and then this whole thing evaluates to a string, one of those. And then a semicolon to conclude the let. And you can do this with anything. Yeah, down here you can have let y equals, hello. And then you have a loop which tries something over and over again until it breaks. When you break, you can put along some result. And this result is then put into y, because this whole loop block evaluates to one expression. And even in functions, you don't need a return keyword. When you just write something at the end with no semicolon, that means it's implicitly returned from the whole function. Yeah, this is how functions look with the arrow, meaning this returns i32, an integer with 32 bits. Yep. Structs. So as I said before, Rust does not have classes. Instead, you have structs. And you'll notice when you in Java write something like this, this implies that these both fields are public, or I think package public or something, package private. In Rust, you have to explicitly say pub to make them public. And instead of writing the type before, you write the type afterwards. But yeah, that's just a small difference. When you want to create an object, in Java, you would use the new keyword to generate some kind of default file and then set the fields afterwards. Or you write a constructor. But I wanted to compare these two for now. when you want to create an object in Rust, you can use the same file syntax as above with the curly brace, and then path colon, and instead of writing the type, you now write the actual content in that type. And this would be a string. Ignore this to own for now. We will come to that later. And false is just a Boolean. This is how you would create an object. Now you can write let x equals, and then this thing, and now you have a file in the variable x. This continues. Here we actually write a constructor now. In Java, you would write a constructor like this with the same name as the class and some arguments, and then you already have some kind of default file given, and then you can change some fields about that file. In Rust, it's a bit different. Constructors can have any name. I called this one open to open the file, but it can have any name. It does not have to be the same name as the file, on the class. And the return type is self, which refers to self as in the type we are currently implementing. And yeah, you also notice that the struct file is just defined over here and does not have the functions in it. In Java, you would write everything inside this class. In Rust, you also only have this struct definition and then an implementation block below it or in some other file. And you can have multiple implementation blocks, or you can implement interfaces for another type and so on. This is a bit more flexible in Rust. Yeah, and then we just use the constructor.
Compare it with C#, because this is C# 15 years ago on the website.
Is it? I'm not familiar with C#.
Yeah. Far more like the right side. Even
Nice.
sometimes better.
Yeah, it seems like the modern languages convert on some kind of standard. And I really like this notation, which might look weird at first sight, but I think the more you use Rust, the more you learn to love the syntax and the way it works. So yeah, you get some path string and you assign it to the path. And we always set open to false by default. And this is just a getter. Instead of writing get path, you usually only call it path in Rust. And you return a reference to the path in this case. OK, this is the way you would use it at the end. So in Java, you would call new file constructor with the string. And in Rust, you would call : open. And this : syntax is something you always use when the left-hand side is a type. So when it's a type, you use : When it's an object, you use a normal dot. This is the way you differentiate it. And yeah, you notice this path function we had before uses self as an argument, which is similar to this, the this keyword in Java, but you need to take self and it's an argument. You might know Java has static functions, which mean functions that don't need an object to run. You could write static function main, for example, and you don't need an object of this class to call the main function. The main function can always be run. And in Rust, there's no concept of static functions. Instead, when you write a self as an argument, that means it's a member function. You only can call it on objects of the class. And when you leave out the self, it means anyone can call this function with the : syntax. This is why you can call this function with : and this one with a dot. OK, yeah, and then you can create a new file and print a path like this.
One question.
Yes?
So in Java, I think, and also in or many other languages, by the new operator, the object is on the heap. But how is it in Rust?
OK, by default, it's all not on the heap, on the stack. But some objects live on the heap. For example, when you create an object of type vector, it lives on the heap. Why can I not? So by default, this is on the stack. But for example, a string is not on the stack. A string would be on the heap. So it splits up.
It has an anchor on the head, on the stack that points.
Yeah, you just store it's a fat pointer, basically.
Yeah.
A pointer with some additional information.
Yeah, like it's a structure on the stack which has a
Right.
reference to something on the heap.
Yep,
So it's
correct.
It's a dual thing.
Yeah, all variables in any language live on the stack, but some point to the heap, and some have all the information in the stack. Right, good question. This is an enum. Who of you used enums before in Java, which looks like this? Enums, anyone? Nice, okay, some of you. I don't like Java enums. They're so boring. You just have, are they called as are they stored as numbers on Java? I'm not sure. But
Generally, maybe where you can't access.
yeah. In Rust, they are far more powerful. You can have the same enum here with closed, loading, and open for the state of the file, but you can attach additional information to the enum. Like when the file is loading, you can save the time since it was loading. Like it was loading since 2 days ago. Why is it not opening? Or when the file is open, you can attach a string to that type, to that item of the enum. And when you have an open file, that means you also have the string, like the content of the file. And you can see in the syntax below, here we create a closed file, again with the colon syntax, because we mean the type, file state, we want the closed variant, or we want the loading variant, and then we can use the curly braces, similar to this one. It's the same syntax as above, but instead of writing the type here, we write an actual object, like system time now, which is the current time of the system. Or when you have an open file, you can put a string in there. So you can have named fields. This field has a name, since, or you can have unnamed fields or tuples, which look like this. So you can attach more information to enums, and that makes enums so powerful. You use them all the time. And a lot of the standard library comes down to enums with some things inside them. And yeah, they're used all the time. How do you actually work with an enum now? Let's say we have a file state of some type. We want to do something with it. Maybe the file is already open and we want to print the file. Maybe it's not open. What do? We use a match. Or in Java, it was called switch with different cases. And apparently, you need a default version as well for Java enums. I guess in case you extend it later on. In Rust, you can have the whole list. And when you forget one case, the compiler will crash at you. You need to write all the cases of which could be possible, like the file could be closed, could be loading, or it could be open, and there's nothing else, so this is fine. If we forget like closed, the compiler will say, hey, you forgot to handle the closed variant. Here's how to do it. And yeah, you write, this is called a pattern on the left side, then this arrow, and then what would happen if that pattern matches. And you can have a pattern with a variable inside of it, and this will try to match the file state object we have with this thing, and we'll create a new since variable we can use inside the print line to actually use what we have stored in the enum. And the same with the open over here. We can now use the content inside this curly brace. Yeah. So this is the main way you would use matches. And matches are like the basic version to handle enums where you always handle all the variants. But in some cases, you're only worried about some of the variants. So here again, we have the file state, the same one as before with closed, loading, and open. And maybe you're only interested in open files. Like we have this file state. Let's do something if the file is open. So if you can create a new variable, like let is always the word for creating a new variable. But here's a pattern now. If you can let the file state match this enum variant here, then you will have this C inside of it, which is a free variable. And this would be the content of the file again. So if you can put the file state into this pattern, then you can use this C. And this is the curly brace. And you can do that. Or maybe you want to do something over and over again and always try to pattern match. This would be the while let. So you try to get some state and see if it's loading. And if it's loading, then we print still waiting. And because it's a while loop, we start at the top again. We'll try to get the state again. If it's still loading, we print still waiting, and we go to the top again. And maybe now the file is open, so the pattern doesn't match, and we continue later on. Or maybe we don't want to nest everything so deeply. So with an if, you need to put your actual code inside these curly braces. With a while let, you need to put it inside the curly braces. What if we just want to write file content on the same level as the call before? This is where we again use let, not if let, but just let. And maybe this fails. Maybe the file state is not does not match this file state open, then you can use an else, and you need to like end the program somehow here. Like you need to return or crash the program or something. Because after this else is done, this code will assume that file content exists. So it will assume the file is open. Yeah, and this syntax is really nice to use with enums. You can handle lots of situations with it. Yeah, and now just one example struct to have a bit more fun here. Like this was all about enums. Now we have a struct again, vector. We learned before vector is stored on the heap, but we have a reference to it on the stack. And you can call new, which creates a vector with no space at all, first of all. And then you can push some items onto it. Now we have a vector with 3 items in it, and probably the Rust compiler will also have some space, like have an additional space over here for more elements in the vector. Like on the heap, it already has space for 16 more elements or something to make it more efficient to add more elements. Anyway, when you have a list, you can get the length. You can pop one element, which would remove the last element you added, like 14. You can remove the first index, like the 12, or you can clear it all, and then it's all gone again. And Rust has really great documentation for these things. You just go to Rust docs vec. I recommend, so I put on my laptop, I did right click, I added a keyword for the search. So in on my laptop, I can just write rs and then vec, and will automatically open this documentation, which is really nice. Then you can see on the left here all the methods that are possible on vectors. Like you can deduplicate them, you can see the capacity, you can drain all elements and return each one. You can insert them at a specific place, and so on and so on. There's a lot of functions. And maybe we want to look at the vector in a read-only way, which is what these are all. Yeah, there's so many of them. And also for string, many ways you can handle them. Strings. Before using Rust, it's a char pointer. Strings are just char pointers. After using Rust, there's a lot of different types of strings. For all who know Rust already, you can try to figure out what each of them does. Like some of them, let's see, OS string is the way your operating system stores strings, which is different from how Rust stores strings, which is different from how paths are saved, or C strings when you need to interoperate with C code. There's so many strings. We will only need 2 for now, 2 types of strings. One is just called string, which is an owned string. And about ownership, we'll have a slide soon. But this is a string where we actually have the full string. I think it would be a string builder in Java. We have the full string, and we can add more characters, remove some characters, replace something, and so on. We have the actual string. And str, or borrowed string, or string slice, I think this would be called string slice. It's just a read-only version of some part of a string. Like, I do have an example here. Now on the next slide is an example. This one is for normal strings. You can create a string, push a character, pop it back again, add some words to the string. Yeah, you can just play around with the string. This is a proper string, this string. And when you have a string slice, on this slide all of them are string slices. You cannot change them. Like in this case, this might look like a string to you, but it's actually a reference to a string stored in the program code somewhere. You can't edit it. And you just have a reference to your program code, which has the string somewhere. And you can split at the colon. You see this colon here. Maybe we want to split it in 2 parts, like the answer and 12. And when you use split once, and for error handling, we use unwrap, because not all strings contain a colon. Then we can split it into 2 parts, text and number. And these are also just read-only views into the string slice we had before, number. Or you can directly say, I want characters 0 to 3, which would just pick the keyword and store it as a string slice as well. OK, how do you convert between them? When you have a string and want a read-only version, you just write the borrow sign in front of it. This is not entirely true, but this can dereference into the right type. So when you want a string slice, you write this. And when you have a string slice and want a proper string, for example, you wrote this static string somewhere and want to change some characters and add more characters and have fun with it, you use .toOwned to convert it into an owned string. There are multiple ways to do this. I prefer toOwned because it implies having ownership over the type, which is important for ownership. Any, maybe some questions about the slides so far? Yes?
What's the difference between two strings? Like on the method or on the name ref?
So this is...
There's also two string, right?
There is two string as well.
Yeah, what is the difference? Do you know?
It's the same. It would compile to the same thing. The difference is when you change your code and maybe you put a number in here, number.toString would still compile and would still convert it to a string. Maybe you don't like that, because in this case, when you change nameref to a number, this would fail because it's no longer a string after this. There's also string.from or this point .into. There's so many ways to convert these. Just use toOwned. Any other questions? Okay. Ownership. So I said before, Rust does not have a borrow checker. Rust does not have a garbage collector. Instead, we have the borrow checker and ownership. How does ownership work? Let's say we have a calculator, a struct calculator. Maybe it has an owner. Maybe it has a log file as well, where it saves some things. And all these things need to be managed by someone who will, when we throw away the calculator, we don't need it anymore, who will also get rid of the string, who will close the file and save it. And this is the concept of ownership. In this case, the calculator struct owns the string and it owns the file. So when the calculator is removed, the calculator will also take care of the string and the file and will remove those. So instead of needing a garbage collector, everyone worries about their ownership things. So we have the struct here, and now we have a new function, basically a constructor for this calculator. And we put a string, as in the constructor, we take a string from somewhere, and then we save it in the owner. And in the constructor, we also create a new file, open a new file, and save it in this. And this means that while the calculator exists, we will take care of this string, and we will take care of this log file. So the calculator will take care of it. I think I have another example on this. Yeah. Now let's have some examples on how you would, what I mean by getting rid of the calculator. For example, in this first case here, C1, we have a new scope, which is basically what this means. This could be an if or a loop or whatever, or you can just write it like this. Inside these curly braces, there exists a variable called C1, which is a new calculator. But as soon as we leave this block and continue with the other code, this calculator cannot be accessed anymore. And Rust sees this and knows, oh, we cannot access C1 anymore. We dropped it. That means we will actually drop the calculator, which is the keyword. You can see also here. We will drop the calculator, and it will internally drop all the strings and so on we have inside of it. And these maybe drop other things. And it will just chain down and get rid of all the memory, so we have place for the next calculator. This is the same thing, but instead of waiting for the end of the scope, you can also just call drop directly. And this will take the C2, which is basically saying, this drop function, it will take care of this calculator for me. We put it in there, and then the drop function just throws it away. So we gave it to the drop function, and it just threw it away, and that means C2 is no longer there. And C3, is this ever removed? Yes, this is the end of the main function. At the end of the function, all variables inside of it, all local variables are gotten rid of. And maybe you don't always have ownership of something. Maybe, let's continue with the calculator example. I own this calculator. Imagine there's a calculator in my hand. And I want to give you read-only access to the calculator. Basically, I'm holding it up here. You all have read-only accesses to my calculator. And this would be one case, which would be fine. You're all looking at my calculator. Or I own my calculator. Or in my you don't see it, I own my calculator, and I throw it away, and you all don't see it because you didn't have read-only access to my calculator. These are the two things. Or there can be one mutable reference. Maybe I'm holding my calculator to someone, and they have mutable access to this calculator, typing some stuff in, changing the log files, but no one else. Hello. Oder? So, maybe I own the calculator, but I give someone else mutable access to it. Or maybe I'm typing on the calculator right now. You shouldn't be looking at the calculator while I am typing, because then you would see different things when you look away and look at it again. We don't like this. When you have read access, you want to have this static, basically. You want to see the same thing when you look back and look at it again. And this leads to the 3 rules of borrowing. Either there are no reference to an object, which means I own it and no one else is looking at it. Yes?
That was my question exactly.
Okay.
If there are no references, shouldn't it be dropped?
No references, but I own it still. So let's say I put it in my bag, no one is looking at it, but I still own it. This would be case 1. And in that case, I could throw away the calculator and do whatever I want with it, and you are fine. Or maybe there are any number of read-only references. So I'm holding it up here, you're all looking at it. I'm not typing anything, so you all see the same thing. And this would be fine, but I'm not allowed to throw away the calculator then, because you are all looking at it. I can't just throw it away, you're still looking at it. And also, while you are looking at it, there cannot be mutable access. No one can type at it while people are looking. And I think I have some examples for this as well. Yeah, so in this case, we just have one file. And we create a mutable reference. This is what this means. We create a mutable reference to our log file and store it in this variable. Hello. And that means we can't have a second variable with mutable access. Like when you write another time mutable reference to log file, the Rust compiler will complain and say, nope, you already have a mutable reference. You can't have another one. So we need to drop the first one again. Like getting rid of this first reference means, okay, this reference is gone. Now people can look at it again. And here we have multiple read-only versions of the log file. I'm holding it up. You can all see it. And while people are looking, I can't manipulate it. This is what this means. I can't create a mutable reference while people are looking at it. And when you actually write code, you always have the choice. For example, when you write a function, how do you want to take the file as an argument? Like, do you want to take ownership of the file? Like, want someone to give you the calculator, now you need to worry about it? This would be the first case. Or do you want the second case, which means you can look at the file, but not manipulate it and not throw it away. You don't have ownership, you can just look at it. Which would be the second case. And this would be the right case in this case. The print file, when you just want to print a file, you only need read-only access to print a file. You don't need to do anything else. So you would use this one in this case. You could give it mutable access too, but this is overkill. You don't need to give a printer mutable access to your file. It doesn't need to change anything. Which is this approach of Rust, which really makes sure things happen to your types when you want them to change, and not some random function is changing your calculator and you don't know what happened. So you always know, oh, this function is only taking a reference. This means they can't do anything about it. This is fine. And yeah, when you want to write into a file, you have 3 choices again. I could give the whole file to the writer, but this means I won't have it afterwards. I just gave it away to this writer, so this would be a poor choice. Read-only access is not enough to write into the file, so you need mutable access in that case. Does that make sense? Great. Okay, a bit of a topic switch. We're going back to enums. Enums are these things with multiple variants. And you can also have generic parameters, which is this. T and E, which is some type or an error. And when you have a result, which is the type I mentioned earlier, because in Rust you don't have exceptions, instead you have this result type. This is actually in the standard library, defined exactly like this. And you either have OK with some type, or the result has an error with the type E, which is some error. Or similar to that, you have an optional type. And maybe you know this from some other languages, like Haskell has this as well. I think it's called maybe. You either have some value or you don't. Maybe you have it, maybe you don't. You have an optional variable for this. And here's an example with the file. A file could have metadata, for example. It may or may not. So we have optional metadata. Some files have it, some files don't. Sometimes it's some, sometimes it's none. And when you want to open a file, maybe you realize, oh, we cannot always open a file. We can only open a file if it exists. So you have an if here. If the file exists, then we return the opened file. And this time you wrap it in OK, which means you create a new object of this result, enum, the OK variant. And inside of it, you put the T, the type. So in this case, this would be an actual file. So you would return a result with a file as T. So to have this OKT. Or in the other case, we return an error, like this variant, with a string over here. And over here, you can see the full type result with this angle brackets with self and string, which is basically T and E. In the OK case, we return self, so the file. In the error case, we will return a string, which is the thing over here.
Why do I need this to owned for the error string message?
Because this one is a string slice, basically the str, and we wrote over here, that we return a full string. So in some cases you do this like this, because I cannot return just a reference to some string, because who will take care of that string? Right? When I just give a reference to some string, someone needs to clean it up later. So in this case, we say, okay, make this a proper owned string, and the person who's handling the result will take care of this, this string for us and free it from memory when it's no longer used. Yeah, you will probably see some errors about this and ask, have some questions later. The Rust compiler will help you a bit. What do we have here? Yeah, this is how you use results. Like now you call file open and you realize, oh, wait, file open, this returns a result now. I can't actually use it yet. I can't see the path or the metadata because it's just a result file. So one case to handle this would be to use .unwrap. So instead of writing just file open, you call .unwrap later. And this basically says if the file is an OK, if this actually exists, then we're fine. We just give you the file. But if it's an error, we panic. Panic is a nice word Rust has for crashing the program. So when you call .unwrap on an error value, you crash the whole program. So unwraps are dangerous. You need to worry about them. Another option you can have is, okay, maybe we try to open this file and we do a match here. If it's okay, we just give you the file, so the file will go into the variable. If it's okay and we have some error, we don't know what to do with it. Maybe we just give it back to whoever called this function. So we turn the error again, not from the open function, but from this function over here. We turn it like propagating it upwards, bubbling it upwards. This is like what you would use with exceptions. When you don't handle an exception, it would bubble up, which you need to do pretty often. And this syntax is pretty long to bubble up an error. So you would use this syntax instead, which is just a small question mark over here. And this would expand to this whole match. Like when it's an error, it will return this error. When it's an OK, we just continue to put the file into this. So when you see a question mark, this would always mean, okay, this could return from the function. This could bounce away. So you need to look out for these question marks. Yeah, this is just another example for the question mark. We try to open the file, and if it fails and we have an error, we have the question mark and we return the string again. And when it's OK, we put it into file and then we return OK with the file, because this is a result too. Yeah, that's basically it with my presentation. Sorry for boring you with all the basics. This is a lot of things we didn't cover. Thank you. Thank you very much. So hash maps, hash sets, all these nice things, macros, which is like the print line macro, traits, really important feature for Rust, so interfaces, iterators for going through a list in a nice way, closures, you know closures, which are functions with some additional data in them, which can be created dynamically, some things for asynchronous code, and unsafe Rust. When you actually want to corrupt memory and destroy the world, you use unsafe Rust. Yeah. Now we have a break, get some brain things, and then we can continue with the workshop. I will show a quick example soon to get started. But yeah, thank you.
Yeah, short 3 things from my side. First of all, thank you very much. I think it was a very good overview for people who are like good in other programming languages already. And so give Timo another hand here. Secondly, I think one guy already said to me he will join Rust Week in May. So if you plan to attend a conference or you want to attend a conference, here are some conferences lying out. On Friday, there's Rust in Paris. We have coupons for this conference if you like need a trip this weekend. But very nice, you probably saw the stickers. Eurorust is also in Paris. It will happen in October. And is another chance if that short term doesn't work yet. I said 3 things. I don't remember. Have fun.